What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live stream where we try to write some cool code from scratch and see what happens. So this week we are going to be, well, I guess today, I won't say this week because we don't really know yet what we're going to do on Thursday, but today at least we're going to be looking into how we can improve the build for the game that we've been working on using the new Mesh build command that I just finished working on over the weekend. And we'll talk a little bit more about why it's important, but for now, I'll just jump into the updates. So since last time, I fixed a ton of issues in the compiler and the VM by writing a lot more code in the language itself, which is a very useful thing to do if you are creating a language from scratch. You need to actually write code in the language to try it out and see what happens. And basically, by doing that, you will find a ton of bugs that you didn't know existed. So I fixed a bunch of stuff. I'm not going to list out everything that I fixed, but I feel like we're at a point now where the language has reached a level of, you could say, early adolescence, in that, you know, it can walk, it can talk, you know, it could do things that are useful. It might be able to drive soon, but it's definitely not like a mature language by any means. But I'm very happy with it. I've been really enjoying writing code with it, and I'll show you some of the code that I've been doing with it a little bit later. I've also added a lot of useful core APIs for things that you obviously are going to need if you're writing any code in the language, like file system operations, operations for dealing with lists and arrays, operations for dealing with strings, and also for managing processes, which is important if you're going to try to shell out to other programs like GCC, etc., like I'm doing now. So we're at the point now where the mesh build command is ready to be used. I actually got it working early this morning, and I'm able to build Mesh itself with its own build command, which is really awesome. So we'll take a look at that too. Hello to IOTCL, not sure. And Robert, thank you both for being here. I appreciate it. All right, so building projects with Mesh. So over the weekend, I spent a lot of time fleshing out the language, like I mentioned, and basically just trying to get everything ready to accomplish a very important goal, and that is the ability to build an entire C and Mesh project, since Mesh is basically a language that's meant to interoperate with C very closely, using my own build tool and project description format. And you're probably thinking, well, why would you bother doing that? You could just use makefiles, you could use CMake, you could use all of these things that already exist. Well, for me at least, it gives me more control and allows me to write and ship my own programs using this language a lot more easily. And you may not be able to see it right now, but over time, as I add more stuff to it and you see me working on projects with it, you'll understand what I mean by that. So building this tool this way really allows me to simplify the approach that I use to build my projects consistently across multiple platforms, like, let's say Linux, Windows, Mac OS, because, you know, originally in this channel, I was basically saying I only cared about Linux, but that was for the original set of projects I had in mind, which were basically just for my own creative tools. But if I'm going to be doing game development, it makes sense to at least be on Linux and Windows. And if you're already on Linux, you might as well try to be on Mac OS as well. So I've done a lot of work in the past getting game projects in Scheme, cross-compiling across Linux, Windows, and Mac OS, and I'm going to make the same thing happen again with Mesh. And this Mesh build tool is very important to that because it's going to allow me to automate a lot of that process in a repeatable way. It also allows me to handle things like dependency management with this language because there's no package manager. So we're going to be using like Git repositories. You need a tool that will automate pulling down the repositories for all the libraries you use. Also, handling different release configurations or build targets and things like that. That's something that you have to deal with whenever you're trying to build a program that needs to be distributed to people. And lastly, packaging apps for distribution. So if I want to give you a copy of a program that I wrote with this language, I have to be able to package that up and make it ready for you using it on your own platform. So there's a lot of stuff that you have to do. And what I've done so far is sort of just scratch the surface and get the basic framework working. But it's a very good starting point, in my opinion. I feel very good about it. And I'm really excited to start using it more for everything that we're going to be doing in these streams. So today I'm going to show you how it works by converting the existing build script for the Crash the Stack game we started working on a couple weeks ago, and the Substratic library, the sort of the game engine library, both to using Mesh build instead of using Bash scripts like I had been using before. So that should be a little bit of fun for me, at least, because it gives me the chance to validate what I've been working on up until now. So if you want to check out the code, check out the mesh-lang /CLI repository on GitHub. And I also have linked to a specific file, the build.msc file, which has most of the implementation of the APIs and sort of framework for how builds work. And you can take a look at that code there if you want to, but we'll see a little bit of that today as well. So for our tasks, there's a few things we're going to do. We're going to create a new project.msc file for Crash the Stack. A project.msc file is basically a description of the project plus all of the build targets that you might want to run. Hey, Emil. And then we're also going to do the same thing for the embedded Substratic library. So that's basically the game engine and graphics library that we put together based on the original work we did for Flux Compose. Now we've broken that out into a separate library, but it's still embedded in the source of this Crash the Stack project. One of the key things about making it its own project.msc file is that it's going to make it so that we can break out that Substratic code into its own repository very soon, maybe even this week. So now we'll be able to have a separate repo for that and then reuse that in other projects, which is going to be very important when it comes time for Ludum Dare at the end of this month, whenever I have to start up a new game using the same code. So having all this stuff working is going to make it very easy to start that new project whenever I need to. Also, we're going to add a function to make it easy to clone a Git repository. So since we're going to use Git repositories for our library dependencies, I'm going to add some functionality that will make it very easy to just clone a repo. You'll see exactly what I mean for it to be easy. It's just basically a simple function call. We're also going to add a function for downloading a file from the web using wget. So I'm not going to write my own HTTP client to download a file. I'm going to just shell out to another program for that. But the idea is that I'm going to use Muscle C for building statically linked C programs using Mesh and using the other code that we're going to pull in. So I need to be able to download a build of that compiler to use it for release builds. So we're going to add some functionality to make that happen. We also need a way to unpack a zip file because we're downloading basically a zip, or is it even a gzip? I'm not sure exactly which type. Well, whatever it is, we're going to write a command that allows us to unpack the archive containing the Muscle C compiler toolchain so that we can use that for release builds. And we're also going to try to add a way to switch between GCC and Muscle C for compilation, probably like a debug versus release build configuration. Not sure how I'm going to do that yet, but we'll figure it out when we get there if we have time today. And then lastly, we'll try to delete the old build.sh file, but I don't think we'll be able to because I still need to automate a couple things before we can really get rid of that completely. Mainly on CI. I need a way to get all the dependencies on CI first. So that's it for the tasks. So let's take a look really quickly at the project file for the Mesh command line tool so that you can see a little bit about what I'm starting from. So the way that I set up the Mesh compiler project is that I have the compiler repository, which is used for building a shared it's a static library, I guess you could say, shared library. Not sure which one it is. Basically, it's one where you can statically link into your program. So that if you write a C program, you can easily pull in the compiler to use it for your C program. That's in the compiler repository. Then there's another repo called the CLI repository, the command line interface. And this is where the build tool lives. So right now we have the Mesh folder that we're in right now. And then we have the compiler folder, which is actually the compiler library that I mentioned before. You can see we have this project.msc file. In fact, let me pull the latest on this code because I think that this is out of date. Let me do this really quickly. Pull that. Whoop, nope, wrong repo. Switch to master, pull. Okay, yeah, we're good now. So we have this project.msc file that's in the root of the CLI project repository. If I were to open that up and then turn on scheme mode, I really need to turn that hook on. You can see that we have a scheme file, or a mesh file effectively. It's not really scheme. That starts off by defining the module that it's in, which is really unimportant, but the more important thing is importing the list and build modules. Then we describe the project. We say we have a project with a specific name, a URL to where you can find it, the version number, and the description. So this defines what project we're currently building. And the Mesh tools will be able to look at this project.msc file and figure out exactly what the project is for that folder structure. Then you have this target function that will allow you to define a particular build target. So here I'm defining a target called deps, and each target takes a Lambda function that runs the functionality for that particular target. Now later, we'll have some reusable functions you could use to just sort of, use a function name here instead of having your own Lambda. But at least for now, since there's not a whole lot of functionality yet, I'm hard coding a lot of the targets, but I'm using API functions that I've defined in Mesh build to make this a lot easier, which you can see here in the main target. It's sort of like the main entry point of the Mesh command line interface. So first of all, we tell it, okay, you also need to build the depths target, because this is where we're going to start downloading some dependencies. Then we build a project called compiler/project.msc. So it allows you to call into another project to be built, which is just this compiler/project.msc file here. We'll take a look at that in a moment. Then the actual compilation part happens, where first we run compile files on a list of files where we have, right now it's just main.c for this particular part of the project. And then source path, out path, and then any flags that's into the C compiler. So this will call out to GCC to run GCC on these passed in as a list, and then we'll get the object files out the other end. Then we're basically passing the combination of that list of compiled output files plus the libmesh.a library together to pass to this link program function, and that's what's going to use GCC to link those files together and produce a final binary of bin/mesh. So it shows you that it's pretty easy to set that up. It's very different than using a makefile. This is more sort of a code-centric approach to setting up a build for a project, but I like it this way because it gives me full control over what I'm doing, and I don't have to deal with a bunch of cryptic tools like automake and configure and all this stuff to get my project build working. So to me, I'm much happier for all this. So then at the end, we have target default, which allows you to configure what the default target is. Maybe there's a better way to do that. Like I could have it, decorated on the target itself. But for now, we're going to have this separate function where we can basically just say what the default target is. All right. So that's that one. We're going to take a look at the compiler project.msc also. This one is a little bit more Thanos based. Says the stream is dropping. Great. All right, give me 1 second here. Let me take a look at the... Oh boy, we got some nice little red boxes here. I don't know what's going on with the internet. I'm hoping that clears up. I'm not sure what's happening. Uh-oh. Okay, I think we're back. Everybody see everything okay? That's the lovely part of streaming sometimes. I don't know. I think Restream has some issues these days. I actually think that Restream may be located in Ukraine. So that could account for part of the problems. I'm not exactly sure. Or maybe people who started the company are from Ukraine, but... Anyway, they've been having a little bit of issues lately. I think everything's good now that I've started on YouTube. So sorry for those of you who are watching on Twitch if you happen to drop off, but that's the way it goes sometimes. Okay, let me just get back into it. So we were talking about the build file for the command line interface project before. This is it. We had taken a look at, and I'm gonna go jump into. Oof. Anyway. Jump into the compiler's project build file. So this one is very similar. I think I actually have a little problem. Whoops, little problem here. Let's change this really quickly. Yeah. So like same as the other one, we have a project function here where you describe the name, the URL, version description of the project. And then I'm defining a list of source files, but this is just a normal variable because this file is just a normal code file. It's basically a script effectively. And I'm saying what all the source files are in the project. Now, obviously, I could write a function that could just scan for all the .c files inside of the source folder and use that too. And I might actually do that at some point, but for now, I'm just sort of hard coding them because it makes sense to do it that way, and it's a little bit clearer, I suppose. And then we have a sole target here for lib, where we have a lambda function that does a similar thing where it calls compile files for source path, output path, and then that lists the source files that I defined before, and then calls link static library to produce that bin/libmesh.a file. So those functions, wow, is this still having problems? I'm seeing buffering on my side a little bit. It's starting to annoy me. Okay, anyway, let's go to, let's see, module/mesh/build. And you can see that link static library is really just a, it just sets up the arguments to call this process start function that I defined that calls into the ARRCS command that does the work of creating that static library file from all the object files. So that's pretty much it for everything. I mean, we're just using normal function calls and setting things up so that you can describe your project in a simple file, and then the mesh build command can go run that stuff. So I'm not going to go into detail on what the mesh build command is doing because it's just, you know, basic mechanics. But right now what we're going to do is try to replicate what we've done so far in the Crash the Stack project. So those of you who joined before on YouTube, is the stream still up? I think it's okay. And I want to say hey to Jackson also. Okay, so I'm going to copy this file. And then I'm going to jump over to the Crash the Stack project. And first of all, I'm trying to decide, well, okay, let's start with the game binary first. We're going to follow a similar strategy as what I'm doing here. So I'm going to go into crashthestack/project.msc. And then here we'll have crash the stack, flux harmonic crash the stack, maybe flux harmonic crash the stack. Okay. And then we'll change our project details, crash the stack, and then flux harmonic crash the stack. And we'll leave the version that way. And then, excuse me, a hacker themed Mahjong game. That's what we'll go with for now. Why is this fundamental mode? Scheme mode. Thank you. Thanks, Jackson. All right. So depths, we'll populate that in a little bit. But first of all, we are going to go, well, let's comment that part out really quickly. Link program bin/crash the stack. And then this compile files list. What do we all have here in source? I think it's just oh, we have some vendor stuff. So we need to compile some of these things in, which is going to be real interesting. That's cool. Good to know. Let me pull up the build.sh file. I guess I should have shown you that to begin with. So the build.sh file is just a bash script that I concocted to make this project build. So we're going to try to take some of the stuff I've been doing in here and translate it over. So one big thing here is the C flags. This is going to be interesting. I haven't actually done something where I run a program and get the string output as a string. I could definitely do that. I just haven't done it yet. So maybe we'll have to add that. Or we could hard code it for now until I, sort of get around to it. Okay, so back to project.msc. So C flags, I can actually just paste this in right here. Let's just grab the parts of this that I need. I'm going to paste it in right here. And that's good. So let me hard code this. I want to make this easier to deal with. And in fact, we may do kind of like a string append thing here where I can break the string up a little bit so it's not super annoying to read. All right, so we got that one. Actually, let's put spaces after. Okay, we got that. This is where it's nice to start having these API functions like string append where I can start building strings and doing the things I need to do. Okay. Cool. And then this one, this package config command, let's pull up package config, what was that? C flags glfw3. glfw3. Okay, I gotta go into geeks shell. Okay, so geeks shell. There we go. Let's do it one more time. Package config. Oh boy, that's a lot of library paths. Come on now. All right, let me jump over to, well, vterm is just killing me sometimes. Come on. And then project MSC. Okay, there we go. That's better. So instead of this package config, I'm going to make another variable here. Define glfw flags. And I'll paste this right in because I don't want to deal with it. Ooh. Yeah. Okay, let's do this. Right there. Okay. And then that should be good enough. Okay, so now we have this defined for all these flags. I'm going to say to do shell out to package config instead. Okay, so now we have that where we need it. I can replace that with package, oh no, just glfw flags, C flags. How about that? Did I type that right? glwf, fw, glfw C flags. Okay, there we go. All right, so that's enough to get that in. And we only have the main.c right now. I should mention here, that's something I didn't say before. I'm not pre-compiling mesh files yet. I am planning to pre-compile mesh files to bytecode files and then include them into the binary, but I haven't gotten there yet. However, this tool, the mesh build tool, is basically the way that this is going to happen, where I'll make it possible for the bytecode output of the compiler to be written to files, and then I can include it into the binary using GCC, and then generate like a shim C file to make it easy for the mesh runtime to find those bytecode files that have been compiled into the program. So it's gonna be really cool when I get that working, but I haven't gotten to it yet. It's gonna be pretty soon though, I think. All right, so let's see. We're appending the compiler libmesh.a file. We're probably going to include some more things here as well for linking. So let me take a look then at the build.sh file. And we have libs. So I need some libs here. Some of these I'm going to have to grab the output from package config, obviously. So we have C flags on the linker step also. We don't want the fsanitize stuff in there right now. We'll have to add that later. So let's just take that out. Now, C flags is kind of wrong, I guess you could say. Let me take a look at build.msc. Did I have something else? I thought that I had like a libs. C libs. Okay, C libs is probably what I want, but I haven't added it here yet. Where do I put that in the build script? So the libs come in the end before the debug flags. Okay, so I could do C libs here. I already have a C libs parameter in link program. So inside of project.msc, I could have, let's see, instead of C flags, I'm going to say C libs here. And then for these two, I'll have to grab the output to make those work. So let's go up here, define glfw libs, and then I'll paste this temporarily so I can just rip out the stuff that I need. So, whoops, that's not the right one. Paste, thank you. Jackson says, is the game using OpenGL for graphics? Yes, it is. All right, so -L Okay, so that's good. We'll have this one here. And then the same thing for GL. I think we're probably going to have some more output on this one. Okay. Oh, no, it's just about the same. So that's cool. We'll grab this line and then go drop it in right here. So that should be enough to get that working. So I'll append that here. So string append. And then glfw libs. All right, and then for C flags, let's see, what am I doing right now on the compiler build? Yeah, I'm not setting any C flags there, so let me just leave that off at the moment for crash the stack. I'm not going to put any flags in. Well, no. Maybe I do need to put in the include path. So what about the -I? I have that, right? Project. Yeah, okay, I have the C flags there. So that's compiling for the output files. And then when I link everything together, I don't need C flags. I just need C libs. Okay. So then we have all of our libs here. Let me add a space here so that it gets written out right. That should be enough to build what already exists. So this is not calling out to build the compiler yet, which the one of the points of Mesh is that you actually pull in either a precompiled library or, well, more than likely you're gonna be building the library code from C yourself, but the build tool is gonna take care of that for you. So pulling that Git repository down and building it will be a part of many projects, pretty much all projects, unless you just build a C project without any Mesh in it using Mesh build, which is possible. All right. So let's go on to actually see if this works. I can go to the console and, oh, one thing I haven't done yet. I need to get an actual handle on the build program. So I actually have a build on CI. So this was from earlier today. I started producing artifacts that you could download to actually mess with the Mesh build tool and the compiler, basically. So I'm going to save this file. I hope it doesn't take down the stream. All right, it seems to have downloaded it. So we're going to go to downloads, and then there's a Mesh. Where did that go? Show in folder. This is probably not going to do anything, is it? Oh, boy. Okay, so Mesh. Where does it download this stuff? Can I control where it goes? Can I right click? Save as? Save what? No. Save link as. Let's go to downloads folder. I'll bet money is going. Wow. That is not where I expected that to go. Home/downloads. That's good enough. Mark says, it sounds like you have a dinosaur in your home. Yeah, that's what you call an unhappy 3-year-old. I'm sorry about that. Sometimes I try to just keep talking to cover it, but apparently it wasn't possible today. You know, after a long day of being at daycare, my kid is just not happy to cooperate. All right, so uncompress again, because that's the way the GitHub Actions operates. Now we have a bin folder and a modules folder, and that's actually coming from the CI system. So we've got a pre-built version of the Mesh CLI, which is pretty cool. I'm going to grab the contents here. I'm going to mark both of these and go back over to projects/code/crash stack. Whoops. And then I'm going to create a tools folder. I'm just going to go. Yeah, do I want to put a Mesh folder inside of this? Yeah, let's do that, Mesh. And then paste these. Come on. Paste, paste, paste. God. Okay, I gotta go back to downloads again. Sometimes my Dear Ed food is not working in my favor. Okay, so Mesh. All right, I can probably just take this whole thing. Let's try that. Go into projects, code, crash stack, tools. Let's delete this folder and then paste the other. Yes, paste the other one. Okay, so now we should have that in tool/mesh bin. Okay, cool. So Let's try to run that really quickly. Tools/mesh bin mesh. I know that's a little bit ridiculous. I'll just run the command first to verify that it works. Okay, it's writing output, mesh compiler, blah, 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 builds a mesh project. Okay, so I can type in the build command here. And then, let's see, undefined variable string append. That makes sense because I did not put the string module in here. So mesh string. All right, so now I'm going to run it again. And, oh, okay, so we've got some leftovers from having compiled it with a libasan, so I need to go clean all that stuff out. So since we actually see it doing something here, I think maybe it's a good opportunity to go and try to get the Substratic. No, I can compile the compiler here. Let's do that. That's what I want to do, actually. So let's do this first. I'm going to pull this in. And then I will delete the contents of the bin folder and the compiler/bin folder. Then I should be able to recompile everything. So let me do the rmrf. All right. And now let's run mesh build again. And it seems to have done some of the work, but I believe we're missing the Substratic libraries now. But I think it did pretty good, though. We compiled the compiler part of the code. And then also we started compiling main, but we didn't have access to the Substratic library yet, so we're going to start doing that next. Hello to Mark and Leonard. Well, no, Leonard is a spammer. And Luis and Gavin, thanks for coming. All right, so what we also need to do here is another build. So if I go into source/Substratic, I think this folder needs its own project.msc file now. So what we'll do is go back into project.msc. We'll say source/substratic/project.msc. We'll say target lib also on that one. And now we got to go and make that library. So we're going to do the similar thing as we were doing for the compiler. We're going to make a static library that gets compiled in completely, basically. And let's go try to do that. I'll go back to the project file for the compiler. I'll copy all these files. I'll go into crash the stack, source substratic project.msc. I'll paste this in. And then I can call this Substratic engine. And then I'll just change up the project details a little bit. Substratic engine. Substratic engine. Okay. And this is the Substratic engine library. Okay. Gavin says, Mesh is your language, right? Yes, it is mine. So source files. Let's see what source files we need to pull in. File.c. Well, actually, I think we can just copy them from the build.sh file because we did have those baked in here. So I'm going to take these files. Yeah, GLAD and SPNG need to be a part of Substratic, so I'm going to pull those into that build as well. We'll go to this project.msc and then let's drop this in right here. I'll take out all of the Substratic paths because we have that. Now the vendor files, let's hope that my relative path resolution is going to work here. And we can delete the rest of this stuff. Nope, not that. So let's just take the stuff off. Follow to parenthesis. Okay. So we have our list of source files here. And that should be good enough. So now, source files. Let's say bin/substratic. We didn't need this before because we were just compiling directly into the program. But now that we're building a library, we need to have a... let me put that in /bin. This is going to be interesting because I haven't tried kind of getting out of a folder with relative path resolution. So we're going to see whether this works or not. Source path also is kind of a problem. I may need to move the source files around a little bit to make this work. So maybe it makes sense to do that first. So let's see. What do we have that we have changed so far? Okay. So what I'm going to do is go into this folder and I will create an actual legitimate project structure. So I'm going to create a source folder. I'm I'm going to create a modules folder. I'm going to mark these files. Whoops, I just messed that up. Mark that one. And then I'm going to go into the modules path. I'm going to... Come on now. Okay, I messed that up. Mark. MSC. Mark. Go into modules, capital Y. Which one is it? Come on now. I always forget what my key binding is for copying these things over. Come on. Unmark, thank you. Sorry, folks. This is a little bit ridiculous to watch. Mark. All right. No. What did I do wrong here? Did I do something here? Okay, that's fine. Unmark that. So I've yanked those now. Go put them in here. Good God. I swear. Okay, let's just do this the right way. Normally, I know what I'm doing in DRED, but today this is not working for me. So I'm going to move all .msc files into modules. I'm going to move all .h files into source and all C files into source. Okay. Systems. That needs to go into modules also. So move systems into modules. Okay. What did I do with a project file? That's weird. Okay, now it's back. Okay, so we have our source file folder. We have our modules folder. That's good. So now let's go back into project.msc. We can fix some of the stuff we did here. So these two things are correct now. We can also leave this as bin/substratic.a because, in fact, maybe we should call it libsubstratic. And that's going to create a bin folder here, which is good. And also the other libraries, we may need to pull those in to that subfolder. So how about if I look for vendor/cglm, I'm going to move that into source. Same thing for GLAD and SPNG. So GLAD and SPNG. So let's take a look now. Okay, we have all those things there. That's all of our sort of compiled in dependencies, which is nice. Cool, so now the Substratic library can take care of building these parts and not have to push that responsibility up to the Crash Stack project. So let's go look at that one again. And I think I can take some of these things out. So I'll copy this and go back into project.msc for Substratic. We don't have a C flags here yet, so I'm gonna drop one in like that. And make sure that all my parentheses line up correctly. Looks good. Let me do this also. Whoa, what did I just do wrong? I think I may not have a matching paren somewhere. Hey, Ashraz. Okay, can you line it up? What's going on right there? Interesting. The C flags is just hanging out in space. What are you doing? What are you doing? Okay, I don't get it. Somehow Lispy is not indenting my code correctly right now. That's fine. I'll fix it myself. Okay. Oh, it's fundamental mode. No wonder. Scheme mode. Thank you. So we now have link static library. We have compile files, source bin. We have our... Ooh. We need to compile with Mesche compiler. We have like some dependency relationship here between the two. It needs to compile against the headers. That's all we really care about. So let me do ... there. That's not good. We're going to have to fix that. But I need to think about how to deal with that effectively. Okay. So now we can try to build this library and see what happens. Let's also change these. Since I've moved these files around a little bit, we're going to say, oh, we don't even need to say that anymore. You just use the normal paths. And that should be enough. Let me double check the C files. So file, log, render, shader, texture. Let's split that window really quick. Just double check those file listings. Window, texture, shader, renderer, file, log. Okay, that's good enough. So we got our source files listed out here. And we have all of our include paths. I don't think we need to link against anything yet, because the host program will be responsible for that. Okay. So we can try to build that too. Let's take a look at, we have a project at MSC there. I'm going to use /tools/mesh bin mesh build. Okay, undefined variable glfw C flags. Oh, good. So I'm going to do this. Okay. spng.o, no such file or directory. Oh, I gotta create the subpaths too. I forgot about that. So the compiler does not like... Oh, I got a little bit of an error here as well. Should fix those. Doesn't like not having the output file paths already made. So I need to do a couple of ensures here, I think. So ensure output path. Did I export that function? If I didn't, I'm going to have problems. But I can just call, what was it? Directory create. So we're just going to hack this in. So we need to have /bin/spng. Same for, well, I don't know if I need it for CGLM. Let's check build.sh, make dir. Yeah, output dir. Well, pretty much for any of these output file paths. Okay, that's probably something I need to add into the compile files function, which I'll do another time. So CGLM probably, I don't think that GLAD needs it, but I'm going to do it anyway. So let's try this now. Undefined variable create. Okay, that's fine. I just need to go and pull in mesh fs. Let's see. Bin glad. Ooh. Did I do a glad? Okay, it is glad.c, right? Oh, glad/source. Whatever. Okay, so some of this is working. Window.o. Bin/window.o. Let's check it out. Bin. Yeah, none of the, hold on. Okay, file log shader. Did I have mesh.h, no such file directory? It's not finding the header file. Interesting. So let's check project. No, this one. Compiler include. So this is in the, yeah, I think it's // since we're in the source folder. So / from Substratic, / from source. Okay, let's try this again. Okay, I think we did actually get that to work. All these warnings, ignore that. This is stuff that I know about. Yes, Ashraz, we are making our own build tool right now. Or I've already made it, and we're just converting the projects over to use it. You know, the Substratic library and Crash Stack as well. I've already converted Mesh over to using it. Okay, so let's see. So we've got the Substratic bin file here, which is great. Let's see, how big is it? 279K, probably because we statically compiled some stuff into it. Now in compiler project.msc for, oh, my project, right there, this one. We can also pull in the source/substratic/bin/lib substratic.a file. And I think that should, I haven't seen that one, I think, but yes, I'm sure whatever it says is probably right. I'm not saying that this is a sane thing to do, but it is what I want to do. All right, so now we're going to build the project again. Oh, I got to fix the path here. It's under tools. So tools, mesh bin, mesh build. Okay, so can I access bin, crash static, no such file or directory? Okay, so we got some things here that aren't being added incorrectly. I think the clibs aren't being added incorrectly because I'm seeing library references that aren't being resolved by the linker. I wonder if the Substratic library needs to have that in its own linker call. It must need that. So let me try to add that and see what happens. So I'm going to go back into project for Substratic. And then for the link static library, I'll say clibs. We'll just do those first and see if that helps with the problem. I need to recompile that lib file. So cd source Substratic. Let's run this one more time. And then LDD. Is that going to work on this? Bin / lib Substratic. Yeah, okay, whatever. Let's do this. Still have the same problem. So let's make sure that I'm actually writing out the correct path. I'm gonna make a little ninja edit to the module file here in modules mesh build. This is not going to be something that will be checked in yet. That's one that I'll have to probably. So this clibs is what the CLD flags is supposed to be. So I need to rename that. Thanks for the reminder. Okay, so link static. I want to grab the linker invocation. I just want to look at what it's writing out effectively. Oh, did I not? I don't put the link. Okay, that makes sense. So clibs not being passed along. Output files, add another space, clibs. That would make some sense. Cool. So maybe I don't even need to do this yet. Let's just double check. We're gonna go back into. Well, no, I don't need to do that because I've set this up right. So tools. Ashra says we probably want to be able to add our friend fsanitize address again. Yes, I'm going to do that immediately. Let me tell you something. Address sanitizer has been like the most critical thing I've ever started using for, well, definitely for C development, but maybe any tool I've ever used for programming in general. Like it's made this so much easier. And I have to give thanks to Ashraz for pointing that out to me originally with the Flux Compose project, because like tweaking the garbage collector or just cleaning up bad coding that I did in certain parts of the VM or the compiler, like it was so much easier with address sanitizer. So yes, I'm gonna make it easy to turn on address sanitizer. I've got a whole idea here where when I finally get this stuff working to where we're using mesh build for everything, I'm gonna create an interface using transient in Emacs so that instead of using the compiler interface or the compilation interface, I'm going to use my own interface that makes it easy to rebuild and also to set flags like turn debug on and off or turn address sanitizer on and off, stuff like that. So it's going to get a lot more fun here pretty soon. We're going to do some cool integrations with Emacs. So tools, mesh, bin, mesh, build. I have this project parameter, project / source Substratic project. So this will actually build it in the right folder. I should have been using it this way before. Deps specified more than once. What did I do wrong there? Lib deps. Okay, let's actually write that out then. So clibs. Is that right? Yeah. I do need to check this then if it does end up working. Okay, so linker invocation. So Substratic is the output. SPNG, clad, window, texture shader, renderer, file, log, and then the what is libdeps? Interesting. Let me go directly into that folder. Maybe it's just something weird I'm doing. CD source Substratic RMRF bin. Let's just get rid of that. And let's build it one more time. ////. And then we'll take this project parameter off the front. We're just going to call mesh build directly. Ultimately, I'm going to put mesh on the path so that I can just type mesh build. It's going to be a lot easier to deal with it that way. All right. Libdeps specified more than once. Piotr says, God, I miss C++, got stuck in Java for a few years now. C++ or C and C++ is the elegant weapon for more civilized times. Yeah, I'm having a lot of fun with C. I mean, obviously it's very easy to shoot yourself in the foot, but I'm having a lot more fun writing C than I've had writing any language in a while. So it's been great for me. Oh, God. Yeah, I'm getting weird little drops on the stream frame rate. So let me know if it starts dropping out for you. I'm sorry about that if it does. I think we have internet issues here in Greece lately. Okay. It's interesting that it's doing this. ls bin. Or lsal bin even. So it's not even linking the file anymore because I added those libs. So am I putting it in the wrong place? Hold on. AR libdep specify more than once. Okay, let's look at this. Someone else had something similar somewhere in the world. Come on. Yeah, I definitely have internet issues because I can't even load a website quickly. Something wrong is happening. Now, libdeps. Did I do the wrong thing? Yeah, I've not done this before, actually. Abhishek says, is the name Mesh supposed to be some kind of a pun on scheme? Yes, it is. It's mesh shifted by 2 letters. Or sorry, scheme shifted by 2 letters. Okay, I think that what I'm doing is something wrong with the parameters here. I don't know if I'm even supposed to be doing this with static libraries. So yeah, because I think the linker for the actual program output is supposed to be dealing with this. So why is it not working then? That's the question. We should be. Oh. No. Okay. Create static library link to dynamic library. Yeah. Static library into dynamic library. Not exactly. I don't know. Don't know if it's worth it to try to dig into this right now. No. Okay, how about this? Man AR. What? Okay, I'm in Geeks shell. Man AR doesn't show up because I probably don't have the tools installed. Okay, man AR. Maybe Emacs has it. Let's see, man page AR section 1, archiver known as AR. Okay, yeah, there's definitely not a linker flags in this, so it's just my stupidity in that case. So let's just take that out then. Not supposed to be here. It was working fine before. So I think it's really just creating an archive of all the object files so they can be used for linking later. So we'll just try one more time to to build, whoops, to build that, let me go back into Geeks actually. Geeks shell. And then project, source Substratic project. Segmentation fault, fantastic. Oh, I know why too. I know exactly why. Let's go back into build and take this part right here. I need to do some error checking in some of these libraries. Which file is this? Interesting that it happened again. Okay, let me remove source Substratic bin. Fatal error. Okay, I got a little bit of trouble here, I think. Yeah, -L is ignored in AR. You're supposed to link against dynamic libraries within your executable later on. Yes, that's correct. Okay, so let's go back into bin Substratic. Apparently, oops, source Substratic. Apparently, I need to fix some of the path resolution in the compiler. Or in the build tool, because I think that it's not creating those paths. Oh, actually, no, I hard-coded those, so that could explain a little bit of it. Let's try this one more time. Still, again, can't create it. Bin. Glad, source glad. I swear I put that in there. Interesting that it's not doing it. Oh. Interesting that it's not... What are we doing? Segmentation faults? All right. Whew. Not what I wanted to be spending my time on right now. Let's see. We're going to run... there's a null somewhere. I'm pretty sure I'm passing in that I shouldn't be. Tools slash mesh slash bin slash mesh build. Which folder am I in? Crash stack. Wrong one. Thank you. Bye-bye. All right, let's go into... yeah, this folder. That's great. Just like that. // manifest.scm. Ah, crap. Gets more complicated when I have to pull in the Geeks manifest stuff. There we go. Run. Yeah, always string append. Okay, so something I'm doing is there's a bad value or a null value in there somewhere. So something I'm passing in, probably, let's see, append. Yeah, I took that out. Yeah, I'm sorry, folks. The stream is just totally screwed right now. I think that the internet is dropping out constantly. If you see my screen here, I've got a red block half the time. So I don't know what's happening with the Wi-Fi. Okay, see, it probably will drop again. So let's just see if we can get through all this stuff. All right, C flags. Let me double check what I had done before. Make sure I didn't add anything in here that shouldn't be here. Oh, it's this one, because I'm an idiot. I left it here. That explains everything. Okay, yeah, this whole bit here, we'll just take it out again, because we don't need that. Okay, so lsal bin. All right, the file is back now. cd ... And now we can try to build it one more time. I know it's not going to work, but we're just going to get... our brain back together here after seeing that happen. Yes, well, it wasn't that. It was actually my my code is not expressing good error handling at the moment. Okay, so let me just check the little bit rate there. Okay, so let's fix this little problem. I think that we're almost there to where we can build something with the project. So let's try that really quickly. Go back into project for Crash the Stack. The clibs. We need to see the output for that one on link program. So if I go do the same thing here for link program, right before the process start, linker invocation, we'll delete this string append. We'll go grab this one here. Ah, I'm not putting clibs, no wonder. Okay, so that explains why that's not showing up either. I need to make sure that these are populated. Once again, are we... yeah, we're starting to have a little bit of streaming issues one more time. So that should work. Let's try this right now. Segmentation fault. Fantastic. Go back into Crash the Stack. We are using clibs on link program, but we're not using cflags. So I need to make sure that these are empty strings if they're not populated, which is something I can do, like if not clibs, set clibs to empty string. So this is something that I'll be able to fix with the OR expression pretty soon. I just haven't actually gotten the OR operator working correctly for that yet. So cflags, set cflags. All right, and I think this is gonna work now, so let's just get rid of that. How about this? Let's just try it out one more time. Okay, so I think it linked it. Let's try to run it and see if it works. bin/crash the stack. And undefined variable texture load. It's not, oh, I changed the module paths, so that explains that. So let's go into source main.c. Now I need to add source/substratic/modules as a module path because I changed up how everything works. So if I go rebuild, which should work, substratic renderer.h, no such file or directory. Okay, I need to go and edit that project file, projects, and add the correct substratic include path also. So let's do this. Drop this in source/substratic/source. And then build it one more time. Okay, there we go. Still complaining, no such file or directory. Ah. Okay. Huh. I'm not loving that, but I'll do it for now. I gotta change the way that I'm dealing with my header files, and it kind of is a little bit gross. We're gonna do it this way though. So I'll do it like that, and then in main.c. Oh, you know what? Really? Okay, that's fine. I think I need a single include file that has a single registration function that just takes care of everything and doesn't. You don't have to like know how to use it yourself. Let's do this. I think this is the trick for now. Then we're gonna fix it later. Okay, cglm, no such file or directory. Renderer.h. I guess we're gonna have to pull those args across. This is really good exercise for me because I'm starting to see what the implications are of building something like this that has dependencies. All right, so substratic/source. All right, let's do this now. Okay, now it seems to have compiled correctly. And then if we run, where was it? There it is. Still undefined variable texture load. Interesting. texture load in Substratic modules. No, hold on. I think I still need to fix that path. No, that's right. Remove Substratic from the include line. It's needed. I think that probably the stream is behind right now. And hey, Felipe. Man, this is the worst day for streaming. I gotta say, like, I've never seen the internet be this bad. I may have to cut it early. Yeah, I could have only rendered.h, but it feels like if I did that, it would be confusing. So I'm gonna change my include strategy at some point soon here. All right. So the module load path is not getting found correctly. In modules, we do have texture, and that does have texture load in it. So we need to get that working right. Oh, I think maybe it's not dot source, is it? I guess from the current directory it is. ls source Substratic modules. Oh, okay. Yeah, that's not gonna resolve correctly. I gotta fix that. So in modules, I need to put these in a Substratic subfolder. Okay, so let's go to source Substratic modules. Let's make dir Substratic MSC to Substratic, and then move systems to Substratic. And now I think that the path should resolve correctly. There we go. Okay, so now we finally have the game running again, and everything's been compiled using Mesh build, which is great. So we got some work to do to smooth that whole process out, but that's okay, because I mean, all the raw material is there, and we're gonna get there very soon, I think. So let's see, anything else we need to do right now? I gotta clean up some things. I also need to patch the build.msc file a little bit, because I did have to make some fixes here to make that work. So this thing I need to also do up here. Anywhere that I have these flags that are going to be used in string append, I'm going to have to ensure that they have a value. So I'm going to do this really quickly. Let's drop that right there. Actually, yeah, that's fine. And then where was it? There was a link static library where I also had a clibs. And I think that doesn't make any sense. So if I just take that out, it'll be better. So yeah, we don't need libs here. We don't need anything else either, really, for that. It's just, you know, we need the output files and the target file path. So if I go grab this whole file, I can put that into the real mesh build. So I can check that in later. And I should be able to see the changes that I've made here. All right, that looks like everything that I intended to add, which is great. Okay, so now, let's see, what have we done so far? We created a new project.msc file for Crash the Stack. We created one for the embedded Substratic library also. So next is the stuff for pulling repositories. So let me just double check what I did so far in Substratic. I think that we're sort of looking better here now. We have the source folder, we have the modules folder, and the bin folder where everything sort of gets built to, and the project file. So this is at a point where, in theory, we could pretty easily separate it out into its own repository, which is good. The only thing is like this part right here, okay? We need to figure out a way to not depend on, don't depend on the parent project's mesh header, if possible. I may need to have a way to deal with that a little bit more elegantly, but for now, I'm not too worried about it. So there's another to do here. I need to make, let's see, make compile files, create all intermediate output paths for each input. Okay, So that's what I'm going to do. These will be unnecessary once compile files is able to say that, oh, okay, there's an output path I'm creating based on input files, and that the intermediate paths need to be created as a result. Cool. Okay, so what we'll need to do in Crash the Stack in project.msc is clone our dependencies. So I'm thinking of something like this. If not file exists compiler, select the compiler source path. This is a very temporary thing. We're going to have a full dependency implementation at some point, but for now we're going to do very simple, straightforward things that work. So basically see if the compiler path is there or not. If it's not there, then we basically just use like a git clone, https github.com/meshlang/compiler, and then clone that into the compiler path. And that would be good for that one. Also, if it doesn't exist, we would pull in the Substratic library. So I think sort of begs the question, where do we put our dependencies? Would it be like a deps folder maybe? We can start with that. So how about that? Deps compiler, deps Substratic. And then we can say deps/substratic. This one will only be relevant once we have this stuff split out into a separate repository, or separate repository. Substratic/engine. So right now we'll just comment that one out because we can't do it yet, but this one we could actually try to do. And then once we have that cloned, we could change this to deps/compiler/project.msc. Yep, that would work. Let's see, is the stream dead? What's happening right now? I'm getting mixed signals from the YouTube. Oh, wow. Is it not live? Okay. Jeez. Sorry, folks, for the terrible stream quality today. I apologize about that. All right, so deps/compiler/project.msc. Okay, so now we need this git clone function. And I'm going to write it here right now because it's not easy to put it into the actual mesh build. So I'll just have it be something that we write in this file, and then I'll move it to the place where it needs to go. So define git clone repo URL local path, I guess you could say. So really what we're going to do is just say process start and string append git clone repo URL, and then space, and then local path. And it would be, in theory, just that easy. The only thing we need to do first, though, is ensure that path exists. So ensure output path. Probably just need a normal standard library function for ensuring that a path exists, or just creating it, whatever. Let's actually just use that instead. Yeah, directory create deps. Okay, so that should be enough. So we can try this out. Now, this deps target can be run separately. So maybe we can just try to do that really quickly. So we don't have a deps folder yet, but if I were to run tools/mesh bin mesh build deps. All right, undefined variable directory create. We need to go pull in direct mesh fs. File exists. Okay, do I not have something for that? Let's see. Where am I? Oh, yeah, obviously. FS. Path exists. That's the one. Okay, that's actually a better name, which I'm happy about. So file exists, path exists. So let's run it now and see what happens. All right, process start. I need to pull in the process library also. Mesh process. Compiler already exists and is not an empty directory. Now, why doesn't exist? Oh, because I put it the wrong place. How about that? deps/compiler. Try it one more time. And now we're cloning into deps compiler. And we see all the output of the process there, which is great. And it seems to be actually printing correctly. I'm actually doing a process output pipe here, which is encouraging that it's doing the right thing. All right, so let's look at deps/compiler. Cool, so it did pull it down. Let's try then to compile it as part of the compilation step. So now we've already said compile deps/compiler, so let's just give it a shot. Instead of saying build, we're just going to say build deps, or we're just going to say build. In fact, we could say build main. And it seems to have compiled Mesh correctly. So we've got our first step towards downloading a dependency and then compiling it as part of the build, which is great. bin/crash the stack. Seems that we are good. The compiler, this is the new before. Oh no, it is the one from before. I'm wrong. So let's try this now. Let's just use the deps/compiler. I'm gonna remove rmrf bin. That's good enough. Just bin by itself. So we'll rebuild this now, and we should have relinked it. So now if I were to run crash stack again, then we have the newer build of the compiler library, which is great. Okay, so that's a pretty done task right there. Man, I'm really annoyed by this stream quality today. It's really bad. I'm sorry, folks. Okay, so downloading a file. Now let me double check what I was doing with the build.sh. I was downloading a tar.gz file. Okay. So I'm going to have to untar that, which is fine because I'll have access to the tools for that. So we will try to download, we'll use a temp directory. We'll try to download that file. So if I were to go into right here, I can add another function. Let's see, define download URL, local path. I guess you could even say that too. Process start. Let's go into this. I'll copy my little wget invocation here. Okay, drop that like that. So then for wget, we're going to split. We're going to do a string append. Later, I'm going to have formatting functions that will make it easier to format these strings without having to just append them all the time. So it will be not so nasty. URL, another space, and then the -o, and then the local path as well. So let's take that out and say local path. All right, so that should be enough to run wget. So in deps here, I'm also going to check to see if not path exists, deps. Well, let's see. What did I? Maybe it's a muscle C. Muscle. What do I have here? Muscle. Okay. Man, what a nightmare. Okay. So if it doesn't exist, we're going to have to download it. So maybe we need another function to wrap this logic. Define download muscle and say local path, I suppose. Yeah, sounds good. And then we can directory create local path. Then we can download URL. For now, we're just hard code the URL that I have, which is this one here. And Then the local path would be local path. Then we'll also need to untar that file into a particular folder. So I might need to think about how I'm going to do folder management here, because I don't want to have two separate folders you have to pass in, like a temp folder and then. So download URL to local path. And then we're going to use process start to unpack the local path file. Maybe we don't even need local path because I'm just going to set it myself. Yeah, that's fine. Local path is just a path. So how about this? We're going to say download muscle. Where is it? Yeah. Download muscle to the /muscle folder. Okay. That should be enough. So now, go back to download muscle. We're going to download, and we're going to join this path. So string append local path / muscle.tar.gz. In fact, we probably needed to create a local variable for this. So archive path would be here. Archive path, join that line, go here. And then this should be part of the string. Okay, so now we basically created a new path for muscle.tar.gz. No, in fact, we could do it in the local path even. Man. We could do it in the local path and then unpack it directly to that folder path. So let's do that. I mean, it's not so clean, but we'll improve it a little bit later. So right now we can resolve yeah, how about this? What we'll do is do a little string append. All right, and then yes, local path, right? And then this one is going to go directly to our local file path of, whoops, muscle.tar.gz. Okay, so then we're going to untar it directly into the local path that the user specified. And that should be enough. So then download muscle will download it into this local path. So let's actually see if that works. And in fact, we want to delete that after, but I don't have a delete start. I can just delete the file like this. rmdir muscle.tar.gz. No, not rmdir. gz. So just rm. To do use a library function for this, which doesn't exist yet. Okay, so now let's see if we can get muscle downloaded. I'm going to move the current muscle folder to muscle old. And then I'll run, well, no, not build main. I must have messed up some code somewhere in here because now I have an unexpected token kind. Sounds like it's possibly too many close parens somewhere. How about let's use check. Come on, where are you going? Check parens. Then where is it? Interesting. Let's see. How did I screw that up? Let's go to deps instead. Deps, unexpected token kind 2. Which file did I edit? Aside from this one? Oh, it's the let here. My mistake. Do we even need that now? I'm not even using an archive path. Okay. That's probably why that slide. All right, here we go. I need better errors for that parsing problem, I think. All right, so now, okay, it's going to go ahead and download that. Oh, it's oh, okay. This is probably not going to work because my internet's having trouble. So we'll see how long this takes. You see how slow this is going. It gives you an indication of how bad things are right now. I think the router needs to be reset or something. Okay. 15K per sec. That's great. 3 hours, 2 hours. Seems exactly like the kind of time frame we have here. 94 minutes. All right, it's speeding up a little bit now. Okay. Well, clearly this is going to work whenever the internet is not having horrible problems. So we may have to just sort of assume that it's going to work. But I'm kind of happy with what we've gotten done so far as adding the new functionality that is needed for dealing with the dependencies. So let's see. I'll just kill this. We don't need to drag it out. So I can say that that one is done. Yeah, so I guess I could add a function also for dealing with unpacking. So in project, I can say define unpack tar. Or, well, archive is a little bit too generic. Let's say, yeah, let's be specific on this one. I don't know exactly which library this would go in, but it's something, well, it probably just goes in build, but something useful. So, archive path, output path. And then we were using this process start for that before, so I could just go drop this in right here. Output path. And then in this right here, I could make this into, okay, it's already a string append, so we're good on that. So archive path, archive path. And then -c output path. I think that's good enough, right? That has everything we need. And then now we could say unpack tar gz muscle.tar.gz and put that into local path. I like it better that it looks like it's, you know, it's describing what's happening rather than just calling process start all the time. And then we still have this process start for RM. We don't really have a way to get around that now because I need to add the code for that, which is, you know, not very hard, but it just needs to be done. Okay, so there's a lot of code in this project file. A lot of this stuff is going to get moved out to the actual build library before I get all this checked in, I think. Okay, let's go back to main org. So we did add a function for unpacking a, let's say, tar.gz file, .tar.gz file using tar. I'm pretty sure that's going to work. Add a way to switch between GCC and muscle C. So that's something we could try to do right now. What I need to do is have a way to change the arguments that I send, like basically the compiler flags, because right now I'm not, the compiler name. So do I have a parameter for that? I probably need to add a parameter for that. So if I go back into build.msc, compile files has a C compiler parameter, which is good. We need that. I'll also add a little bit of a thing here. C compiler, we're going to default that to GCC just to make sure that we don't run into any trouble. And, I'm already seemingly doing that here, but now I can just remove this out of the let and use C compiler here. We'll just assume that we have that value at hand. And we're going to need to do a similar thing for link program. So we're going to need a C compiler there as well. So C compiler. And let's do the same thing. We're going to copy this line and drop it in right here for C compiler. And instead of GCC here, I'm going to use C compiler. So now that will give us the ability to use a different compiler name, which is going to be useful for swapping in muscle C instead. We're going to have some issues with static linking here on this program, I think, because we have a lot of dynamic libraries. So it'll be interesting to see how this goes. All right, so now inside of the project at MSC for Crash Stack, I don't have a way yet for user-specific parameters to be sent to the build program, which I will need. Or a way to specify a specific configuration. That's going to be kind of useful eventually. I mean, one idea that I have in mind for that is like a config release. And then that would create like a build config object of some sort with a compiler and some other flags and stuff that get merged in to the build parameters for various different things. And then if you say, I want to use the release versus the debug configuration, let's see, debug, build config, compiler, GCC. In this case, the compiler would be, what is it? If we look at build.sh, we can find that it's this muscle bin whatever. So we would just put that into parentheses here. The idea that I have for how I would manage this sort of setting configuration parameters for things. And then I could have a parameter to build. So I would say like build deps config equals or config release or something. Something like that. Seems like a good way to go, I think. Something similar to this. It may not be exactly like this in the end. This syntax is a little bit weird, obviously, because it looks declarative when it's actually a function call, and normally you would be doing like a define. If I had macro support, which I'm going to add at some point, I would maybe use a different approach for this, but I kind of like the way this looks so far because it's pretty clear what's happening in the file. You have targets defined, you have a project definition, and also your configurations for the project. So we may go with that for this for now, and then I might change it later, depending on how I feel about it. That's just the way this project goes, or all these projects. I'd sort of just do what makes sense until it doesn't make sense anymore, and then I change it. Okay, so let me take 5 minutes and see what I can do here. I think I already have a build config record type. So let me look into the build.msc file, build config. Okay, so I do have a record type for that. So this could work in a function for config. Then these two could work, and then I could also add a parameter for config that would make it possible to load these. And then any of these, ooh, I have a parameter here. So lambda config. Config could be basically the parameter, and when the user uses a particular config in as a parameter to lambda, so you don't have to do any kind of checking yourself as the author of the build file, basically. Config, lambda config. Okay, so I do like that. Okay, so that's both of those lambdas. Now, the other thing is, what if you need custom arguments or custom parameters? I may need to have some kind of a list there for extra parameters. Not sure how much sense that makes, though. Oh. 0 frames again. Just thinking about whether a lot of this matters or not. So build config is all good. It's good to have that. Good to have the ability to specify specific C flags to add. And then that would also mean that possibly things like compile files would not need to have explicit C flags. We could specify those elsewhere, like in the build configurations. So instead of having all the flags down here, maybe you would have them up here on the build config instead. I'm just thinking about, like, would you have the same set of debug and release configurations for both your main program or a library or even the test runner? I'm wondering if maybe the individual targets need to have their own settings for build configurations, but that may be going too far. I don't know. We'll have to experiment a little bit with that, but I think that so far this is a good approach to take. But we probably won't write it right now because the stream is having so many issues that probably it's better to just stop the stream early. So let me see if I can compile, or sorry, not compile, commit some of the stuff that I've been doing so far. Did I do anything new here, I wonder? I'll go back into the other build.msc right in, was it here? Go to the bottom. And let's see, compiler C flags. Okay, I did add that. Okay, that's good. So this could be committed. So basically we're fixing some issues in the build library or build module. So I can say build fix some issues with compiler and linker functions. And then that's good enough to push up to the build or the CLI library. What about in the compiler path? We did change that, but that's actually the wrong one. Let me grab that line. I could do it here. Let's go check in crash the stack and see if the compiler, yeah, this hasn't been changed at all. That's good. So now we can go back to mesh, compiler, and then just fix the repo path. Project, fix the repo URL. All right, so I'll just push that up now. And then inside of crash stack itself, we've got a lot of stuff we need to try to commit. So first of all, we need to move all the Substratic stuff into its own folder structure, which needs to be updated at some point. But for now, we're going to do it this way. So all these files that were deleted, let's go check all these, stage them. Then it will recognize that those are renames. Okay, so let's do this right here. So renamed Substratic, vendor, blah, 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 blah. All that seems to be good now. And then I need to change these and the module path in main.c for that to all line up. And then also add the project.msc file and make sure that one looks good. Nothing else that needs to be done at the moment. Nope. Okay, cool. So for this commit, we can say separate or reorganize Substratic library to enable extraction into a repo. Okay, that's better. And then the last thing would be to set up the project.msc file for crash stack. Add project.msc. Okay, so none of these need to be committed. And what I want to do now is just go and I want to delete everything and try to rebuild it from scratch and see if it all works. So rm bin, compiler bin, and a source Substratic bin. And if we can see that this actually works, then I think we're good to go. And we can say that this stream was mostly a success. But I might need to change that one line really quickly. So let me delete these first. Let me make sure it doesn't try to go download that file again. So project.msc, let's just turn that download muscle part off. Download muscle. Get rid of that for a moment. Now, let's see. Let's see what happens. We're just running build. Okay, a little bit of issues. Oh yeah, the stupid folder creation thing. I don't know why it has to be run multiple times before it picks that up. Okay, so now it seems to have worked. No such file or directory. Is that their same execution? Nope. Okay. Let's see now. Let's see what happens. bin/crashstack. Okay, so it seems that we actually did manage to build crashstack, mesh compiler, and the Substratic engine library all as part of running the mesh build command. It needs a little bit of work to polish it up, but I'm pretty happy with the fact that it does work, and it's a great starting point to build from. I also think that this whole, downloading dependencies and managing them as a target is also going to work really well. I just need to go finish up this code. I'll probably just do that tomorrow morning. So anyway, I think that's going to be it for today because the stream is just not cooperating. Let me just go and we haven't finished that yet, so we'll just leave it as it is. But on Thursday, I think we'll see what the sort of end result is of all this. I'll have a lot of it working by then, and then we'll get back to the game development part. So we'll start looking at the actual game logic and implement some of the basic behavior. I'm going to try to make a few sprites for the tiles to have something interesting to look at. I'm not a good artist, so it's just going to be messing around a little bit, but we'll have something to put on the tiles, and we can randomize them so we can start trying to add the logic for clicking them and checking for which tiles are actually playable, etc. Which is basically the point where it starts seeming like a game. So hopefully by the end of this week, we'll have something that is starting to look like it's playable, and then next week we can start adding some cool functionality to it to make it more fun. And probably I'll have it even set up to the point where I can be shipping binaries of the game so you can download it and try it on your machine. So that should be pretty fun too if we get to that point. So anyway, thanks a lot for those of you who came today and suffered through the constant dropouts on the stream. I see that there's some people still here. I don't exactly know what happened with the stuff today, but I'll make sure that the internet is a little bit more solid next time. So until next time, thanks a lot for watching, and keep it creative. We'll see ya.